In this video, we're going to learn how to find the domain of a function. And so we have two commandments of mathematical domain. I just made that up, but that's what we're going to call them. And the first one is thou shalt not divide by 0. So I put over here, for example, 7 or any number divided by 0. This is considered undefined. Can't do that. The second commandment is thou shalt not take a square root of a negative number. And then I put in parentheses or any even root. In this lesson, all we really care about is square roots, but just know that this rule applies to any even roots as well. So 4th root, 6th root, 8th root, so on. And so when I take the square root of a negative number, in this case, -1, that becomes I, and that stands for imaginary. So we cannot take the square root of a negative number. So in our examples here, we need to find the domain of the following functions. So in this first one here, and by the way, if you didn't get a chance to write this down, just go ahead and pause the video and write it down and then resume. But in this first one here, I need to worry about making sure that I don't divide by 0. So I'm going to take whatever's in this denominator, and I'm going to say that it cannot equal 0, and then I'm going to solve. So we'll add 7 over, and we find out that x cannot equal 7. Your homework's going to ask you to write this in 2 different ways. The first way is set notation. And so in set notation, we'll have the set of all x such that you don't need to know what this stands for. This is already going to be wrote for you in my math lab. You are going to be finishing this set notation. And what you're going to be typing in is what you have found out from this equation, that x cannot equal 7. If they ask this in interval notation, this is -∞ to 7 with a parentheses, then the union of 7 to infinity. Both of these answers here are saying the exact same thing. They are just in 2 different forms. The first one's set notation. The second one is interval notation. The set notation is always easier to write because it comes directly from that equation. This one is a little bit harder to write, but it is a better visual, I think. I'm saying from -∞ to 7, you will have answers in that domain, which is the set of all x. Because it's got that parenthesis, that 7 is not included. Same thing over here. It goes from 7 to infinity, but that 7 is not included because it's in parentheses. And so this is basically skipping over 7 and saying it cannot equal 7. And if you plug that in, you'll see why. If you have 7 minus 7, then you get 0 down here on the bottom, and we know we cannot divide by 0 because it is undefined. So same thing on B. All I care about is that we're not dividing by 0. So I don't even need this 2x. Because there's not a denominator with the 2x, I don't have to worry about dividing by 0. And because there's no square root, I don't have to worry about having a negative under a square root. So we'll take what's in the denominator, 5x plus 15, and set that to not equal 0. So we'll subtract 15. And again, we get 5x does not equal -15. Divide by 5. And x cannot equal -3. So in set notation, this is the set of all x such that, and then you are typing in x cannot equal -3. And then in interval notation, this goes from -∞ to -3 with a parenthesis because that 3 is not included. Union -3 to infinity, again, parentheses because that -3 is not included. My math lab is only going to ask for one of these 2 answers, either in set notation or interval notation, but we're going to put all of them in both just so we can get the practice for whichever one it asks for. And same thing, if you plug in this -3, 5 times -3 is -15, and -15 plus 15 is 0. So that is the only number that we can plug in here where we divide by 0. So that means it's the only number that my domain cannot be. On C, when I have h of x equals the square root of x minus 8, now I don't care about dividing by 0 because there's no denominator here. But what I do need to make sure is that I don't take a square root of a negative number. So I care only about what's under that radical, x minus 8. And to make sure I don't get a negative number, I'm going to say that this is greater than or equal to 0. It can equal 0, it just can't be less than 0. So we'll add our 8 over, and x is greater than or equal to 8. In set notation, this is the set of all x such that x is greater than or equal to 8. And in interval notation, this is bracket 8 to infinity. We have a bracket here this time because now it's greater than or equal to 8. So we need to include 8 in our solution here. So bracket means that 8 is included. And if we check our answer, if I plug in 8, because it can equal 8, right? If I plug in 8, 8 minus 8 is 0, the square root of 0 is 0, that's okay. If I go greater than 8 to 9, 9 minus 8 is 1, and the square root of 1 is 1. It's positive, so that's fine. If I violate this condition and I go to 7, 7 minus 8 is negative 1, and the square root of any negative number is not real, it's imaginary. On D, I again want to make sure that what's under this radical stays positive. So I've got 4x plus 12 is greater than or equal to 0. We will subtract our 12 and divide by a negative 4. Now we have already gone over how to solve inequalities, and inequalities are the same way as equations with one exception. And that exception is if I divide or multiply by a negative number, we have to take this inequality symbol and flip it. So instead of x is greater than or equal to, now it is x is less than or equal to. And then over here we get 3. So in set notation, this is the set of all x such that x is less than or equal to 3. And in interval notation, this is negative infinity to 3 with a bracket because it's or equals to 3. So we need to include that 3. E is similar to B in that in B, I did not care about this 2x because that 2x was not threatened to be divided by 0, and it was not threatened to have a negative under a square root because it didn't have a denominator and it didn't have a radical. Same thing here. I don't need to worry about that 3x. There's no way it can violate either of my 2 commandments. So I just care about this 2x plus 8, and I need that to be positive, so greater than or equal to 0. Subtract your 8 and divide by 2. So x is greater than or equal to negative 4. In set notation, this is the set of all x such that x is greater than or equal to negative 4. And in interval notation, this is bracket negative 4 to infinity. We must use that bracket to say that that 4 is included in our solution set. And then my last one here is really a combination of both of these. I have to make sure that my first rule or commandment is not violated by not dividing by 0 in the bottom. And then because I have a square root, I have to make sure that what's under this radical is also positive. So to solve this one, we will do x plus 9 is greater than 0. Notice that all of these other radicals was greater than or equal to 0. But if I set this equal to 0, then I can get 0 in that denominator, and we cannot divide by 0. So this right here is not greater than or equal to. So we'll solve by subtracting 9, and we get x is greater than -9. So in set notation, this is the set of all x such that you're filling in this portion here, that x is greater than -9. And in interval notation, this is parentheses, -9 to infinity, because this 9 is not included. If you include -9, when you plug this in, you get -9 plus 9 is 0, and the square root of 0 is 0, and you divide by 0.